Morning, everyone. I welcome you to the webinar on simulations with Design Builder today. I'm Yashima Jain and I'll be moderating today's session. Now, first, I would like to acknowledge the support of Department of Science and Technology and the Ministry of New and Renewable Energy. I would also like to acknowledge Design Builder as a gold sponsor for Solar Decathlon India. Today's webinar is being conducted by PC Thomas. PC is talking to us from Australia, so it's late afternoon for him right now. Good afternoon to you, PC.
Thanks, Yashima. Good to be here.
So PC Thomas is the founding director of Team Catalyst and also an Adjunct Associate Professor at the University of Sydney. He specializes in integrated building design using simulation tools to assist in the design and delivery of sustainable buildings, in particular in predicting the performance of mechanical services. He has a master's degree in mechanical engineering, 30 years of consulting, research, and teaching experience in sustainable buildings, building energy simulation, energy auditing, energy efficiency in buildings, and solar energy. Today, PC will show us how Design Builder can be best used for implementation on load reduction strategies for effective net zero energy building design. PC, the teams are working towards a deliverable on November 30th, where they are required to demonstrate their pre-design analysis. I am sure they would appreciate your session to learn how they can use Design Builder effectively for that. Now, as always, you are free to send in your questions anytime during the session, and we will take as many questions as time allows during the session. And with that, it's over to you, PC.
Thank you, Yashima. So I'd just like to say thank you for the opportunity to present, and we're very excited to see that there are so many teams participating, and DB's Design Builder is very happy to sponsor all the teams. So what I thought I'd do today is lead you through three things. A set of resources that I think Yashima has already provided some of you. Just a quick look at them. And then what we might do is look at two pre-prepared models that I have. One which has got an air conditioning system, and another one which is, I would say, an engineer designed apartment which is naturally ventilated. Forgive me for the simplicity of the design, but it's quite useful to illustrate what DB can do and what principles are available. So with that, I'm just going to share my screen. Let me do that. So I'll just put that up. And so the first set of resources that I'd like to show you is that Design Builder actually has got all of its help online, right? And it's a very good resource. So I would suggest to you that if you just Google Design Builder help V6 for version 6, you will find it on the web. And all of the documentation is available online. You should be able to search for anything you like. It is a great resource and I commend it to you. Okay. Now, the second thing that I suggest you might all want to look at is that I'm teaching energy simulation for the best part of 15 years in different forums, to my peers, other engineering consultants and ESD specialists, and lots of students. And there is a initial lecture that I give, which I suggest you could do, have a look at. Okay, and it's this one here. You'll find it under YouTube if you look for DesignBuilder Software Australia. And it's the video that says Energy Simulation by PC Thomas. Okay, it's about an hour long, but it steps you through a very logical sequence of what a building energy simulation model is, what are the components that you should pay attention to, and how you can look at analyzing both air-conditioned buildings and naturally ventilated buildings. So there's another resource for you. The third thing that I would suggest that you should really consider doing is, there is another DesignBuilder software YouTube channel. That's the one that is actually set up by our parent company, the UK company that actually develops DesignBuilder. You'll find that they have a series of videos, and I really would suggest that you work through the series of videos about how to do building geometry, how to enter basic model data. So series 2, series 3, and then they do have some series on heating, cooling, design, and on natural ventilation. You can look at those as well, okay? But I will show you some other things that might be useful as we go along. So those are a series of resources which I'm sure you'll find useful. I think I've also given Yashima a PDF printout of the manual, the DesignBuilder Help Manual for version 5. Now, the reason that's useful is sometimes it's useful to read things sequentially rather than the online help, which is, subject-based, and you keep clicking around to get to different subjects. So you might find that useful. Particularly, I would suggest for model data creation, the first 200-300 pages are all about how you can model things. So if you find yourself stuck, look at that PDF, and I'm sure it'll solve many of your issues. Okay. So let's move on. Those are the resources that we've got. Let's move on to just have a quick look at DesignBuilder, and then we'll take a break, and we can probably have some questions at that point, and then come on from there. Okay. Now, DesignBuilder is a very, very expensive program, and it's really a graphic user interface. And the graphic user interface has under its hood a number of calculation engines, and the most well-known is Energy Plus, and Energy Plus is the actual energy simulation calculation engine which sits behind DesignBuilder. And I've just gone to the Energy Plus website. You can look it up. It's a public domain software. It's maintained by US DOE. It's been around for 20 plus years, and it's the 3rd generation software that the US DOE has developed. So there's a lot of documentation which is replicated in DesignBuilder, but if you ever wanted to look under the hood, please feel free to do that. It is, of course, very text-based, and it's very difficult to work with on its own. That's why DesignBuilder gives you access to the power of Energy Plus in a very useful way. Okay, so we were looking at a model. The model is something that we have worked on as part of a research project. The model itself is, because in this case we were looking at air conditioning systems and different kinds of air conditioning systems, the model is very simple. Okay, you will find that I've got a series of 10 floors, and each floor, so this is level 3, level 1 here, each floor I've modeled it as a very simple 5-zone model. And as you start to use DesignBuilder, you will start to recognize that what we see here is that the dark gray is opaque part of the building envelope. The light gray is the windows or glazing systems. And then inside you've got zones. Now what I've done is, this is a very theoretical model, and the way the zones have been partitioned, you can see that they've got this yellow partition, okay? And we call these partitions virtual partitions. They're not really walls, but they're mathematical constructs that air conditioning engineers use so that they can design air conditioning systems for perimeter zones and center zones. If you are not able to calculate the loads that each of these perimeters pose to the air conditioning system, then it's very difficult to size a system correctly. Okay. But on this one, I want to show you more about the air conditioning. We'll just take 10 or 15 minutes so you have a rough idea of what it can do. And then we'll go back to building envelope and we'll look at strategies to make the building envelope energy efficient, reduce the load, as we normally say, right? So on this model, we have what's called a detailed air conditioning system. And the detailed air conditioning system has its own drawing pane. So when you turn it on, it'll show up, and it allows you to select and draw all kinds of components, connect them up together, and then model them, right? So on this system, we have a chilled water loop, which provides chilled water. Here we have 3 chillers. So if I go to what's called the chilled water loop here, it'll show me what the chilled water loop is. And in terms of how Energy Plus represents it, each loop, it has got what's called a supply side. So there are 3 chillers here. They supply the chilled water to the building. And that supply loop has got pumps. It's got a controller. And the controller is the one that decides how the loop is going to work. Okay. Each of these components, each chiller, can be reviewed in detail, can be edited in detail. The loop itself can be set up to work in particular kinds of detail. So as you start to look at them, the more in detail you go, the more you will be able to work with it. So for example, if I look at this chiller, then there's a whole series of things that I can define about the chiller. I can define the design COP, what is the reference temperature for the leaving chilled water, what's the reference temperature for the condenser water temperature entering the chiller, etc., etc. And there are a series of curves which define how the chiller's capacity will be controlled based on leaving chilled water temperature, condenser water temperature, what's the capacity that it's delivering to the field compared to the total capacity of the chiller itself, okay? So it gets complex really quickly, and to be able to use these sorts of programs with some depth, you need to have some appreciation of mechanical systems. So that's the supply side. This is the demand side. What is the thing that is demanding chilled water? Well, it's the coil inside the air handling unit. And you can see here I've got 5 air handling units, 1, 2, 3, 4, 5. And you can see there, air loop 1 for the south side of the building, air loop 2 for the north side, etc. Okay. So if I go from the chilled water loop to the air loop, any one of them, you can see here that there's the air handling unit. The air handling unit's got a cooling coil for chilled water, a heating coil, which comes from the boiler, which is probably unusual in India, but we have them here. There's a fan that blows air through the ductwork, and it comes to the zone. Okay. So again, the same sort of thing applies. You have a supply side, which is really your air handler. This is supplying either cold air or warm air to what is demanding that cold or warm air, which is the zones. Okay. And an interesting thing to be aware of and to note is that in most models and in Energy Plus, you have 2 representations of each zone. Okay. You have a representation which is part of the geometry of the model. So that's where you define what is the zone made up of, has it got concrete, brick, insulation, windows, and what are the inputs in that zone? How many people are there? What sort of things are going on? Are you using computers, faxes? Are you doing cooking? Do you have a process that generates heat? All of those things are defined in the geometric representation of the zone. Okay, the one that is here below. But you also have representations of that zone as seen by the air conditioning system. Okay, they're the same zone in reality, but they are represented in 2 ways. One is the building envelope side of things, one is the air conditioning system sees it. So you can see here that in this zone group, which is the south zone group, I've combined all the south facing zones on all the different floors and put them into this one group, and they are being supplied by this air loop. Okay, so you can have many different ways of putting air conditioning systems together. You can do a floor by floor system, or a facade by facade system, or some combination of the others. Now, this is a VAV system, a variable air volume system. You may have different kinds. You may have chill beam systems, radiant cooling systems, whatever. Right? They can all be modeled within the system. So very quickly, I'll just take you through the other 2 loops, and then I think we can leave it at that for today. So here's my hot water loop. And again, the way it works is I've got a supply side, which is a boiler, which is a pump, which is a controller that supplies hot water to what's demanding heat, and they are the heating coils. And you will see here that there's a heating coil in each air handling unit, and there is a heating coil within the variable air volume box, okay, in each zone. So you can see here that all of these connections can be made. You can control the devices in a number of ways so that you achieve an energy efficient outcome. Okay. Now, the only other loop that's left over is that because we have chillers, and these chillers are what we call water-cooled chillers, it means that the chiller gets hot while it's generating cold water. And that heat needs to be rejected to the atmosphere. And for that, you have a condenser water loop, which is really cooling towers. Okay. And as before, you have a supply side. So the cooling towers are the ones that are supplying cool water to the chillers to keep the chillers efficient. And you can see that it's the chillers that are demanding that cooler water. So from the cooling tower, the water goes into the condenser side of the chiller, picks up the heat from the condenser side of the chiller, comes back to the cooling tower. The cooling tower sprays the water, evaporates some of it, cools the water down, sends it back to the chiller. Okay. So some of this is explained in that 1 hour initial lecture that I do. If you go and have a look at that, hopefully all of these things will start to make a little bit of sense. Okay. So I don't think I'm going to spend any more time on the air conditioning system here. But if there are some questions relating to what I've said so far, I'm happy to take them now. And then we can move forward and start looking at a simpler model where we can start looking at the building envelope and natural ventilation strategies. Okay.
So we have 4 to 5 questions that have come in. So I think we'll take them one by one. The first question, PC, is can we import the models or drawings from SketchUp or Revit to DesignBuilder?
You can. You can't do a direct import from Revit, but what you can is you can export Revit to GBXML, and then you can import the GBXML to DesignBuilder. Okay.
Right.
Now,
thank you. Yep.
Yeah.
Okay.
With SketchUp, it's a little bit more complex. There are some options available. My recommendation to you would be that in some ways it's better to take a DXF, a CAD drawing, and draw the floor plan and extrude it from there. You always get a model that's lighter, and it runs much faster than if you import a model from Revit. And there are videos available for that. We can always go through some, we can go through a session which might help you to do that. Sorry, Yoshima, go ahead.
Yep. Thank you, PC. Next question, how to integrate different types of heating and cooling systems, especially geothermal heat pumps in DesignBuilder?
Okay, that's not difficult to do. When you start to draw air conditioning systems in DesignBuilder, you will find that there are templates available. So you can actually pick a template which will give you something close to what you want, and then you can take it from there. So you'll see there are ground source heat pumps. Okay, those are geothermal systems. So you can pick something with that and then go away and do something that which is, you start with that sort of template and then you modify it to something that you want to do. I think it's too big a question to answer the detail of that. You probably need to watch that initial video on detailed air conditioning systems, which DB UK has, and then work your way through that. So if you think about the system as a series of loops, and just make sure you think through the loops first, maybe talk to someone on a mechanical engineering or an air conditioning design team, figure out how they set it up. You can replicate that in DesignBuilder. It's quite powerful, allows you to do quite a lot of things. What I might just do, Yoshima, is I'll just do a quick thing here. So what I wanted to show you was, let me close that off. Once you set up a model and you do a run, Energy Plus in the background creates a whole series of result files, which DesignBuilder can look at. And DesignBuilder has developed a freeware tool called results viewer. So what I've done is I've loaded a run that I had done previously using this system that I've just shown you. And it allows you to do things like plot. So I've got 3 chillers on this system here. So what I'm going to do is I'm just going to plot the cooling that's being demanded by these 3 chillers across the year. Now the graph will look very weird. That's because this is a graph in Australia, and for us, summer is January, February, November, December, not like in India, which is, you know, March, well, May, June, July, August. May, June, July, August for us is winter. But you can see here that you can plot when each chiller is working. So if I look at, say, 2 days worth of what these chillers are doing, you can see how these chillers are running, right? There's a low load chiller here, and then there are 2 other chillers, and they come on and off because I've sequenced them so that each one comes on when the earlier one runs out of capacity. So you can track things like that. You can look at different cooling coils. You can look at what the cooling towers are using, each of the heating coils are using. You can put what's happening on the outside. So for example, I can plot a second graph with what's happening with the ambient temperature, right? So that allows you to then try and compare what's happening on a hot day and see whether your models are working the way you do. You can use to compare 2 sets of runs and see what the outcomes are. I'll show you a little bit on the other model that we're going to be looking at. Yashima?
Yes. Thank you, PC. We'll take another 2 questions, I think, and then we can begin with the next module here. So another question is, how do you determine the width of perimeter zones? Is it on a particular ratio to floor area or a particular fixed width of the corridor?
Okay, so maybe I should look at that a little bit more. There is a thinking around how that works based on how mechanical engineers in different countries design systems. In Australia, we typically feel that the perimeter zone should be somewhere between 3.6 meters to 5 meters. Okay. Now, this is not a hard and fast rule. It's just something that we have decided in Australia as consulting practice. And it's got a bit of history. You know, a typical ceiling tile is 1.2 meters deep. And so the engineer said, okay, 3 ceiling tiles. Okay. There is research in the world that says that, you know, somewhere between 3 and 6 meters is what a perimeter zone should be. Perimeter zones are required. Maybe I should just have a look at, hang on. So one of the slides that I talk about in that video will probably explain it a little bit better. So here's a floor plan of what looks a bit like a T-shaped building, okay? And it's a real building. We did a renovation on it, and we did a renovation of the air conditioning system on it. So you can see here how this system is set up, okay? So we have north facing up the page. Now, the north in Australia is exactly like the south in India. Okay, it's the sun-facing facade. So during the day, you're going to get sun all over that north facade. Okay. On the east, you're going to get sun in the morning. On the west, you're going to get sun in the afternoon. Now, if you think about it, if I had used the same air conditioning system to condition this entire zone, then somebody would be uncomfortable all the time, okay? The people in the east would be warm in the morning. The people in the west would be warm in the afternoon. And the people in the center would always be too cold because you're designing for some average air conditioning load. Okay. That's the reason why air conditioning engineers divide up blocks into perimeter and center zones, or interior zones, if you wish. So when you do zoning, you need to think about that a little bit carefully. This is a kind of an open plan office, so the zoning for that is a bit different, right? When you do things like houses, zoning is different, right? Typically, you have physical walls. So I've got a zone here, or zoning plan for a house here. There are 2 bedrooms, there's a toilet in the middle. But this living, dining, and kitchen area is one big open plan, okay? You may wish to divide that into, like what I've done here, a living zone and a kitchen zone, but there's no real physical wall here. You put a virtual partition to break it down into 2 different zones, and that allows you to work out the temperatures and the energy use required for these kitchens and living zones. Okay, hopefully that's given you a flavor to answer to the answer to your question.
Right. Yep.
Jump in here with just a quick comment. So the Energy Conservation Building Code ECBC has 5 meters as a recommendation for the perimeter zone width or depth. And that's probably a reference that students could start off with, especially when you don't know your designs and you're still in the earlier stages of your design. If you have a general shape of your building or a block that you want to test out, you can divide it up into 5 meter depth deep perimeter zones, and then the rest can be the center or core zone of the building. And that's just a starting point. And then, as PC said, as your design develops and you know more about your spaces, then you can get into more detailed zoning. Thanks.
Right. Thank you, Prasad.
Yeah, thanks. That's useful. If you do have the ECB, certainly will have good recommendations. I know that's got a great daylighting section there.
Yep. One last question, PC. So, will there be a zone division for radiant cooling systems? Zone-wise division. I'm sorry. Yeah.
Yeah. Well, look, there should be a zone-wise division for any type of system that you design. Now, the reason you do this division is because a zone has got a different thermal response compared to another, right? Now, if you are able to bring your, to make your building such that there is no difference in the load between zones in the center and zones in the perimeter, then you don't need zones, right? But if you have got an interaction with the outside, which changes the thermal response of that zone from the interior zones, you should have a zone. That's the reason for doing zoning. Now, if you were able to devise a facade which completely blocked out the sun in summer and in winter didn't lose any heat in the winter, then you may have a building where there is no difference between any of the perimeters and the center zone. Go for it. But if you have significant differences between different perimeter areas and the center zones, you must have a zone. Oh, well, you should have a zone. I know that people don't always do it, but yes.
Right. Thank you, PC. I think with that, we can move on to the next part of the webinar today.
Thank you. Okay, so what I'm going to do is talk a little bit about natural ventilation, which I think a lot of people are interested in. Okay, so it depends on what you want to do with naturally ventilated buildings. Okay, now what I teach or have been teaching for a while is that if you're doing an air-conditioned building, then you set a comfort parameter that the air conditioning system has to meet. So you might set a temperature band, and you might set a relative humidity band, and that's what the air conditioning system meets. And then your interest in using energy simulation is to say, how can I use the least amount of energy, and therefore the least amount of greenhouse gas emissions, to maintain this comfort? How can my air conditioning system and my building envelope do this together, right? But if you're looking at naturally ventilated buildings, where you're not using a mechanical cooling system or a mechanical heating system, then it's no longer about energy. You kind of saying, well, how can I have the most amount of comfortable hours in this naturally ventilated building? Okay, so your design decisions are looking for a different kind of output. So you're really interested in trying to figure out what's the inside condition in the zones of interest. Okay, now there's a difference in the way you look at natural ventilation or naturally ventilated buildings as well. In the tropics, which is what this picture is, and I'm sure you find hundreds of these kinds of pictures on the internet. I picked this one up as well. In the tropics, what are you trying to do? You're trying to keep the sun off people. You're trying to provide wide corridors, and you've got a building that's open so the air, the breeze can go through. That's the ideal outcome, right? If you're living in the middle of the city and the air quality is not all that great, you may not want to open your windows. That's a different thing. But assuming that you do want to keep the building cool by just allowing the air, then those are your design strategies. Keep the sun off, allow the house to vent, close the windows when it's too hot, try and keep try and open the windows when the outside temperature is comfortable, when the inside temperature is too hot, that kind of thing, okay? So essentially you're looking for a control strategy for openings. You're also designing so that the air actually manages to move from one side of the building to the other. If you have a building where air comes in through one window and then gets stopped, it's not going to show you any responses. Okay, so be careful about that. I had an old colleague of mine who's passed away now, but he used to say, air is stupid. It doesn't follow the architect's arrows. It follows physics. And sometimes that's pretty true, okay? So you have to get your physics right. Now, you see this happening in modern interpretations of naturally ventilated designs. You have a path which allows air to come in, warm air rises, you have a path for it to exit from the top somewhere. You get restricted to narrow buildings, or at least if you don't have a narrow building, you got to have some way for the air to leave from the top, and that allows you a slightly wider footprint. But these are all examples that you can see, right? And these are all tropical examples that you've got there. If you're in a temperate climate, like say Delhi, Delhi has a clear winter season, a clear summer season. It's even got a humid season. In August, it's really muggy in Delhi. I know because I stayed there. Then you want to use passive solar principles plus natural ventilation principles. So you want to encourage the sun to come into the space in winter. You want to keep the sun away from the facade in the summer. You want to allow the breeze to find its way in the summer when temperature conditions are cool, and then you've got to balance these strategies so that across the year they work to give you the best outcome. Okay, and then you might need to supplement that with a little bit of heating and cooling to make life bearable. So how do you do that in DesignBuilder? Well, essentially you kind of think your way through where the entry and exit points will be, where the air will be able to go through the different zones, and then you put in some control strategies. Okay, so in this case I've shown you, you can see there the windows are openable on the left hand side, right? There is a controller which kind of looks at, okay, what's the outside temperature, what's the inside temperature, is it a good time to open or close the windows? And there is a kind of a solar chimney type vent which will pull this air out. Okay, that's a very rough outline of what you can do in DesignBuilder. Now, if we look at a model where we've done this, as I said to you, this is an engineer designed model. Please excuse the design, but it's very useful for me to teach. It runs really quick. Okay, so what I've got is two identical floors. Here's my ground floor, and it's really designed just to have three spaces. So I've just put a kitchen, I've put a living dining area, and then a bedroom. Okay. The interesting thing that I've done on this building, which I use to do a fair bit of teaching with, is that I have cut a hole for the staircase, which you can see here as a little rectangle. So if I put this to a rendered view and then took top off, which I've done now, you can see here this hole that I've cut in the floor plate, which connects the ground floor and the first floor together. If I go to the building and if I take a section, then I can show you that. Okay, so somewhere here, okay, I should be able to see, sorry. Hang on a minute. Let me go back to that visualize view. Yeah, okay. So if I then do the same thing and just cut the top off and look down, it'll show you that I can see the floor, which I've made with, I think, terracotta tiles or something to give it that orange color, but you can see how that works. Now, when I run a natural ventilation model, it gives me outputs that make sense. It gives me outputs like the ground floor areas are cooler than the first floor areas. It gives me outputs where it tells me that I can visualize what's going on by looking at velocity vectors, which you will be able to do in DesignBuilder using what's called the data visualization tab. Okay, so if you see this picture, what you can see is that the blue arrows tell me for every hour, and this is a particular hour that I've selected. The blue arrows tell me the airflow going into the building, and the red arrows tell me where the air is coming out, exiting the building. And this black arrow actually is telling me the transfer of air through that staircase hole. Okay. So when you do your analysis, you can actually start looking at those sorts of things. Okay. Now, just to give you a quick introduction, very quick, you have a whole bunch of inputs that you need to put into DesignBuilder for the model to start giving you reliable results. I don't know if you've heard of it, I'm sure you have. And there's a saying that is very valid in energy simulation, and that is that garbage in is garbage out. Okay, so if your model has got inputs that are not realistic, are not practical, then the outputs that you're going to get as results are exactly that, garbage. Okay, So the way to do that is you start with a model and then you keep improving the model to get closer and closer to something approaching reality. It is a simulation. It's never going to be reality, but some models are useful. Okay, and that's how you should use them. So you have all these tabs on the right. Okay. Now, when you open up DesignBuilder initially, it'll be a little bit different because it's in what's called learning mode. And when you are on learning mode, you'll find that these tabs are on the top there, and the tabs you can see on the top there will be at the bottom, and the right-hand pane will be a help window. It continually gives you tips on what to do next. It's a really good one to start off with, and when you get to be conversant with it, then you can switch it off. You can switch off learning mode, as it's called, and then you can have everything on the same screen. Okay. But what I want to do is to tell you that you have something called an activity tab. And in that tab, you give it a series of things. You tell it, is it an occupied floor? You know, what's the metabolic rate of people? What are people doing in here? Okay. What kind of clothes are they wearing? If you want to do a thermal comfort analysis using PMV, you need to tell the model what kind of clothes it's using and when. So you can give them different clothing levels. You can do that using a schedule as well. Okay. If you're doing air conditioning, then you can tell it what the heating set point is, what the cooling set point is. If you're going to control humidity, you can give it a range of relative humidity that the air conditioning system should meet. If you're not controlling relative humidity, leave it on the default. Okay. If you're doing air conditioning, you should tell it, sorry, not this one, but the one below that, you can tell it how much of fresh air you're going to provide. Your mechanical engineer will tell you that, ECBC will tell you that, NBC, the National Building Code, will tell you that. Then you can think about what kind of equipment is generating heat inside that building. So are you using computers? Do you have a TV screen? Do you have a fax machine? Do you have anything else that produces heat? If you're doing any cooking, you can put some cooking loads in there. So when you put cooking loads, the thing that separates cooking loads from other kinds of loads is that you have a latent load, that is a humidity load, which is different from just putting heat or sensible load in. Okay. So there are many options for you to do that. That's your activity tab. The way DesignBuilder works, you have a tree data structure on the left. The one that's right on the top is your location. The one that's just below that is your building. You can divide that building up into a series of blocks. Now I've divided this into ground floor and first floor. If I went to the first floor, I can see inside, and I can see now that in my first floor, I have 3 zones, which are represented below. In each zone, you can open it up and see what the zone consists of. So I've got floor, roof, 3 walls, 3 partitions and 4 walls, right? In each wall, I can go in there and say, well, this wall's got a window too. So I can actually go into and examine all that way, okay? So the reason I'm telling you this is that the way you do things in DesignBuilder, you must always know where you are in the model. If you get that wrong, you may very well put in inputs that are not anticipated. And the easiest way to think about it is that if you do things at the building level, then that building level input flows down the chain. Okay, it goes to the blocks, it goes to the zones, it goes to the different components that make up the zone. If you have a custom construction or a different kind of window in a particular zone, you can go to that window and change it. Okay, but just be aware, once you've customized a particular component, if you go back to a level above that, say to the block level or to the building level, and you change that, then all the things below that will change except the custom that you change. You can remove that customization, but you have to be aware of that. Okay. Anyway, the reason I'm telling you all that is because at the building level is where I've started to put many of these activities in, but you will need to have different activities in the bedroom, which will be different from the way the kitchen works or the living area works. And you may need to go in there and make changes so you've got the right kind of activities going on. A quick example, your living areas will be occupied by people in the daytime. Your bedrooms will be occupied by people in the nighttime. Okay. What is happening in the living room at night? Well, the occupancy hopefully has gone to a very low level or zero. Okay. So you specify these using profiles or schedules. Okay. And again, it's worth looking at things like the ECBC to give you some of that ideas. Now, I'm looking here at the first floor living area. You can see different colors there. Okay. So the yellows are windows, the green is the hole that I've cut out on the floor, the blue is doors going into the different zones. So everything in DesignBuilder has some meaning as to why it's there. Okay. Okay, let me talk a little bit about construction, because in DesignBuilder you can do quite a lot of manipulation of construction. Now, if I went back to the online help and if I searched for, and I'll show you this, it's called combined construction, and you can look it up as well. The reason I want to show you this is that there is a very nice graphic that explains how construction works in DesignBuilder. Okay, yeah, there's the picture I wanted to show you. Let me make this a little bit smaller. Here we go. So unlike some other programs, in DesignBuilder, you don't actually need to tell the program what is a roof, what is a wall, what's an internal wall, what's an internal floor, what's the ground floor, what's an external floor. It works it out by looking at the adjacencies and seeing what's going on. If it's a vertical component and it faces outside, it's an external wall. Okay. If it's tilted by more than a certain number of degrees, usually 10 degrees or so, it kind of recognizes it to be a roof. Okay, you can have a flat roof, you can have a tilted roof, you can have an attic space, you can have these internal floors, you can have partitions, okay? And all of these, the way it works in DesignBuilder is that you define those kinds of constructions underneath a template or underneath each type of wall in your model, and then it applies it to that model, to the correct place in the model. Okay. And you can go down to the wall and check what's going on. So if I went to the living area and I picked up a wall, then I can actually check that it is an external wall and what is its construction. And that construction should match the external wall that I've specified. Okay, unless you have a different kind of external wall for that particular zone, which you define separately, of course. Within the constructions, and this is something that you can do anywhere in DesignBuilder, the best way to do it is you pick something that is roughly like what you want, make a copy of it, edit it, rename it, make it it yours, okay? So this wall here, I think it's a very simple concrete wall. Let me show you, here we go. So this wall has got 3 layers, you can see that, okay? The outermost layer is a cement plaster render. Then there's concrete block, and then on the inside there's cement plaster render. Very simple wall, okay? For each of these, there is a material. Again, there's a whole stack of materials in DesignBuilder in many different categories. You can explore them. If you find that you can't use any of these, make your own. But the easiest way to do that is select one that's something close to what you want, make a copy of it, rename it, make it yours, okay? And then for each of those materials, there are physics behind it. So conductivity, specific heat, density, all of that is in there, right? You can adjust surface properties. So, you know, if you want to fix coefficients, etc., you can do that. You can look at whether they're in the right order, and you can calculate what is the U value or R value, okay? And if you really want to get to an exact R value or U value, you can use this tool here called Set U Value. And it works when you have one layer of some insulating material. And what it will do is it will adjust the thickness of that insulating material so that you can get an exact U value for code compliance type exercises. But for your design, you can do anything you like, okay? So that's constructions. You can go through and have a look. There's all different kinds of constructions here. Use the resources to figure out what's going on. The next most important part of the building envelope is obviously windows. So you have external windows, you have internal windows, skylights, doors, vents. And in each of those, you have access to a whole series of things, okay? I'll just deal with windows at this point. Now, if you have a regular spacing of windows, you know, there's a series of templates available which you can use. And then DesignBuilder will automatically put a series of windows in that format. So if you got, say, a horizontal strip glazing, you know, you have a window that goes all the way around the building. You can choose a strip glazing, you can define a percentage. There are some predefined ones, you can change them, you can do what you like. Otherwise, you can draw custom windows, which is what I've sort of done here. Although I cheated, I drew one window and then I just duplicated them, right? That is the layout, okay? And within that, you can, if you, my suggestion is if you know the correct U value and solar heat gain coefficient for the whole window, then you can switch off frames and dividers. Don't need to take those into account. It's already there in the definition of your U value and solar heat gain coefficient. You have access to different kinds of shading devices. If you click on the local shading, then it allows you to define a series of pre-built shading devices, and these are physical shading devices that you can put on. You don't have to live with these ones. You can define your own. You know, you can, anything that's red is a custom thing that I generated. But the nice thing is that you can define that. What I'll do is I'll show you that. I'll go to, say, the first floor living area, that zone. So all these windows, and you can see that I've put a series of shading devices here. I'll show you what I've installed, right? So I've got a louver with a 0.5 projection, 0.5 meter overhangs and side fins. And if I look at it in the edit mode, you will see that I can actually, without actually having to draw them, I can describe them. And it's quite easy for me to come up with what's being done. There are pictures there, which you can't see right now, which will show you where each of these dimensions are, and it's a very easy thing to do. Okay, so go ahead and explore, right? Now, in addition to that, you also have got access to what we call window shading. I better take this off. Okay, so window shading has to do with blinds. So you can do internal blinds, you can do external blinds, chicks, as we call them in Delhi. You can decide where you want them, which is these positions, and you can decide how to control them. Okay, you can do a schedule, you can say based on the solar that's incident on the window, etc., etc. I believe there are some 18 different control strategies you can use, but be careful. They don't always all work with all kinds of blinds and louvers. Some controls work with some kinds of internal shading devices, so test them, right? Once you get access to that, you got some fairly sophisticated controls. When should these blinds be operated? You can decide on a schedule. You can do the control of, if you're using Venetian blinds, then you can always control how the slat movements can be changed. A lot of this is directly from Energy Plus, so you can always go and read the literature, either in the DesignBuilder help or on the Energy Plus help, okay? Now, the only thing that I need to warn you about is that when you use window shading, which is blinds, you actually can't see anything physically in the model. You can't see the picture of that blind on the model, okay? You have to look at the results and figure out, is my blind working or not? That's quite easy to do. Deploy the blind in the middle of the day and watch how much sunshine comes through there, okay? But if you're putting on the local shading, the physical shading devices, you will see them, okay? So if you put this into visualize mode, then you will see them come up, and then you know that you've used them, okay? For the present, I'll pull it off for now. So to define the performance of the windows is where you go to the glazing type. And that's where you can then define a solar, thermal, and a daylight performance for this window. If I go to look at this window that I've built, okay, there are two ways of doing that. One is to do a really fairly complex one. You can choose the number of layers, pick the exact glass that you want to do, and the glass has got a whole series of spectral data behind it. It'll model it very correctly. But you may have trouble getting to the U value, solar heat gain coefficient, daylight values that you want. So initially, when you're doing design and you just want to test rough ideas of where you're going, the easier method is to change this definition method from materials to simple. And then it allows you to input whole window values, values for U value, values for solar heat gain coefficient, values for visible daylight transmission, TVIS, okay? And it'll get used. If you do a daylight analysis, it'll use these numbers, right? If you're doing a thermal analysis, it'll use these numbers. This is a very easy way to get started on your design. You don't have to know what products you're using in the beginning. You can do it this way, okay? Although it's called a simple window model, it's actually pretty complicated. LBNL has got a model in the background, which depending on the combination of the U value, solar heat gain coefficient, and visible light transmission, it will put a kind of appropriate incident angle modifier equation in there. Okay, that's what you're using the solar heat gain coefficient and U value anyway for that, okay? So simple, but not so simple, okay? So that's windows. Now, you have, oh, by the way, one other thing that I must tell you about is how do you operate these windows? Okay, so you have got schedules which tell the window when to open or close. I think I've got a schedule that I wrote. Let me see what that is. So let me pull my schedule across. This is the schedule that I wrote for this window. Okay, and I said that these are the critical things for you to know. This is the only time that you sort of look at Energy Plus's raw code when you start looking at schedules. And while there are simpler ways to do it, you will find there's a 7/12 and a daily schedule type operation available. I recommend that you learn how to use compact schedules. They are powerful, okay? You can do in one schedule, you can set up schedule which is different for different weeks of the year, different months of the year, different times of the day, all in one compact schedule. I recommend that you learn how to use them. So here what I'm saying is that from January 1st through to the 31st of March, for all days, Monday to Sunday, holidays, everything, until 6 o'clock in the morning, I've used the number 1, which means the windows are open. Until 22 hours, 10 p.m., so from 6 a.m. to 10 p.m., I've closed the windows. So in the middle of the day, I've closed the windows, okay? And then again, from 10 p.m. to midnight, I've opened the windows. And then I've got another schedule which applies from 31st of, from the 1st of April to the 31st of October. And then another schedule that applies from the 1st of November to the 31st of December. That's the power of the compact schedule, all in one, quick, short schedule. Okay, so that allows me to open and close the windows. And this tab here tells me which side of the window should be open, how much is the maximum opening, what's the discharge coefficient, right? And so you've got a fair bit of control over there. There's a whole section on window control, modulation, etc. in the documentation. Do read it before you start using natural ventilation. Okay. Other things are pretty straightforward. You get to put in your lighting systems in here. If you are doing air conditioning systems, now again, air conditioning systems, there are 2 types. A really simple one, which might work very well for you, where you don't define chillers, boilers, etc., but it works out the thermal demand, the heat load and the cooling load, and you can just apply a COP. So you can say, okay, a COP of 3 converts that load into an approximate electricity outcome. Okay, so think about that if you want to use it. And then you've got natural ventilation buttons and you've got mixed mode buttons. Okay, so you can play with some of that to get you what you need. So there are, I mean, if you're using PV, you've got to define a electrical load center, put those bits in, the PV will work, and then you can integrate your model, right? You can look at the sorts of outputs you want, and there's a number of ways to do that. As you start to use them, you can define what you want as outputs. Energy Plus has got a huge number of outputs, and we can look at that, okay? And that's how you start to work on it. So what I'm going to do is I'm going to pick up, we'll do a, let's see if I've already done this run or not. I put New Delhi weather data in there to run. I think it is New Delhi. Let me just double check. Yep, so I've got Palam Airport, New Delhi. And the weather data is the ISHRAE's data. So that's the Delhi weather file developed by ISHRAE. If you are interested in sizing air conditioning systems, you have some design data monthly or 1 point for the year. You can set all of that and it will auto size air conditioning systems, and that's pretty good enough for what you need to do. Anyway, let me do a quick simulation, and then I'll show you some simulations of things that I did before, so you get an idea of how to use that. Okay, so I'm just going to make a run for a month, so it's pretty quick. All right. And what I've done is I've set it up to run from 15th March to 15th of April. So it's not too hot, not too cold in Delhi. I'm going to ask for monthly results, and I'm going to ask for hourly results. Okay. And I've done a series of, I've asked for a series of outputs, right? And I would like you to go and explore what's possible and what's not. You've got adaptive ASHRAE 55, you've got, you know, Fangers, of course, not very useful. It's not an air-conditioned building here. And I've asked it to report temperatures and other things for all periods, okay? So let that go away and do a run. And when it finishes the run, I'll show you what I call 3 ways of looking at results, okay? And the 3 ways are, one is from the DesignBuilder screen itself. So whatever is loaded up by DesignBuilder. Number 2 is files that G Plus creates in the background, which you can look at. And number 3 is using one of those files that Energy Plus creates and using the result viewer. And then I'll show you how to compare 2 sets of runs, okay? So if you were looking at a naturally ventilated building, what would be your options to reduce the load? How would you increase comfort, reduce energy use if you were driving a mixed mode building? Okay, so your first outcome is, how do you make sure that you have the most efficient building outcome before you start to put on other bits and pieces? Okay, so I'll show you 2 runs that I did pre-prepared, and I'll show you how to compare the results for that. And hopefully that'll give you an idea of things you can go and have a look at. So this run is finished, right? It's showing me a series of things: room electricity, temperatures, heat balance, total fresh air in air changes per hour, okay? So suppose I go to a particular zone. So first floor living area zone, okay? And it will give me a series of graphs. Now you can change these graphs. You can look at series of data here, okay? How you set it up is on this left-hand bottom corner panel. And the reason I did this run actually comes out now. Okay, get my bottom graph. It is the amount of air changes which are a sum of mechanical ventilation, natural ventilation, and infiltration. Okay. And what you'll notice is that in the first half of this simulation, okay, you can see that there are some big air changes going on, 25 air changes per hour. Okay. And that's the equivalent of opening your windows up when you've got, you know, the kind of plan that I have, which is not very deep, has lots of windows, right? And I've left the windows open. I think I've left the windows open by 50%. So half of every window can do natural ventilation. And then suddenly here, all of a sudden, I no longer have any air changes per hour, okay? And that's what I wrote that schedule for. Till the 31st of March, I have the windows open at night from 10 o'clock in the evening till 6 o'clock in the morning, and then they're closed during the day. So these air changes are taking place then. From the 1st of April, I closed them. So you can see that there are no air changes taking place here. So the model kind of reveals that my control strategy is working. You can see that reflected in temperatures. Okay, so before, when the windows were openable at night, you can see here, and let me make this so that we're looking at, say, less number of days. So these are 7 days. Okay, so if you look at any one day, okay, make it 2 days rather than 7. Okay, if you look at any couple of days, you can see what's going on here. Okay, this dark blue line is the outside temperature. These 3 lines here are the inside temperature for that zone, living area, first floor. And you can see what's going on. As soon as I open the windows, the temperature in the room drops closer to the outside temperature. Okay. The mean radiant temperature drops, but much less slowly. So what you feel is closer to this red line, the mean radiant temperature. And this green one is simply an average between the two. That's called, in this case, it's the operative temperature. Okay. So you get an idea of how the building is working. Now, once I go further into the space where I'm no longer opening the windows, I don't see that drop in temperature at night. Okay, so my ventilation strategy is working. Okay, nice to know. Okay, so that's a quick introduction to what you can do by just looking at what's going on here. You can examine, if you've asked for the right outputs, okay, you can examine what's going on. Say, for example, I look at a window, okay, and because I've asked for the subsurface outputs, it actually tells me what's going on in the windows. Let's pick a day where there is a reasonable amount of air. Okay, how about one of these? Okay, so you can see here this window is acting, the blue line is air coming in, the red line is air going out. So this window is mainly acting as an air going out kind of window. Okay, you can see what's happening here. This is the incident solar radiation. This is what is coming through that window. This is the heat gain and heat loss from the window over 24 hours because of U value, because of temperature differentials inside and out. And this is the, it's a single glass window, so the inside surface temperature and the outside surface temperature are pretty much the same, the green and the red lines, and the dark blue line is the outside air temperature. So there's a lot of material you can look at. Okay. Okay. Now, I told you there were 2 other ways of looking at things. Okay. Number 2 is if you go to the file and folders and Energy Plus folder, you will see, if you look at my timestamp, okay, it's about 5:45 p.m. in Sydney. You can see that all these files, about 19 files, okay, were just created then. And that's when Energy Plus ran for that 1 month and those outputs came out. Okay. So number 2 run is, if you look at this file, which is an HTML file, it is a standard report that Energy Plus generates. Okay. So if I open that up in a browser, you can see here, okay, it tells me that this run was done over 768 hours. It is in the full year simulation. It's done for New Delhi. And then there's a whole series of reports. Okay, and you can search through those reports. Now, those same temperatures that we were looking at, they are here. We were looking at the first floor living area. So if I look at the air temperature, then it'll give it to me as bins. Okay, so you can see that it's only filling up some of March and some of April. 15th of March to 15th of April was our run. And also it gives you temperatures for hours in that space of time. So a lot of data is possible, and you can set these things up to get what you want. Okay, that's number 2. All right, and you can, depending on which options you tick on the outputs tab, you can generate a whole series of outputs. And I suggest you explore them and decide which ones you need for your project. Okay. Now, the third thing is actually this file here. It's called an Energy Plus standard output. It is the output file which contains hourly values of everything that you might have asked for. Now, what I'm going to do is not look at that one, but look at a couple that I generated earlier on to give you an idea of how you can use them. Okay. So I did 2 runs and I've got results for them. Okay. Now, what I did, to give you an idea of what I did, was I said that, okay, in summer, how do I make this building more comfortable? Okay. So now that strategy will probably not work for winter, but it works really well in summer, and it gives you a really good idea of how to do that. So what I did was I drew a roof, a second roof on top of the first roof. Okay, about 1 meter above the building, just a thin roof which is shading the concrete flat roof of the first floor. And then I actually compared the runs of one simulation where I didn't have the fly roof and another one where I did have the fly roof on. Okay, so how do you do that? Just to give you a quick idea of, if you wanted to draw that in DesignBuilder, you've got something called a block, and the kind of block you want is a component block which provides shading. That's its job, basically. I've just made it 1 centimeter thick because anything. It's just a strategy. Hold down the shift key so that it's on the same plane, and I just drew a very simple roof. Now, when I do that, it will draw it on top of itself. Okay, and what I should do is, if I select that, just to show you that, you can see that. Okay, and what I will do is I will select that roof and move it up. Now, when I do it now, it's not going to be really clear, but say about 1 meter away, I plonk it there, and all of a sudden I've got a shaded roof. Okay, and you can test how that works by looking at the rendered image. Okay, you can turn on the sun, look at the shadows, look for a day, and see, this is now 21st of June. Okay, now suppose I do it for say March. Okay, the sun's going to be a little bit more angled. You can still see it does do its job, although if I was really going to be careful, I might have made the fly roof a bit wider than the roof itself. So I'm just doing a really quick one to tell you what's going on. Okay, and what I did was I have copied the 2 ESO files, put them in another folder, changed their names. Okay, and then what I did was I actually lifted them together so I can see what's happening with the 2 runs and compare what the outputs are. And here are the outputs. Okay, so if you look over here, okay, look, and if I choose any day, right? So let me just pick a day where it is quite different, okay? So you can see what's going on here. The air temperature in the unshaded case is 33.6, 33.7, okay? And this is, okay, what time is it? Make it a bit bigger so we can see that. Okay, so that is 6 o'clock in the evening, right? And then for the one with the fly roof, the temperature is 28.6. So I've got how many degrees? 3, 4, 5, 5 to 6 degrees reduction in air temperature by doing this one strategy. Okay, outside temperature, you can see in the green. At that time, the outside temperature was 27 degrees. So there's still potential for this room to fall. And then it looks like I've opened the windows at night. And then you can see here, as soon as I open the windows, the air temperature again dropped. And the two cases, one without a fly roof, one with the fly roof, they both drop in temperature, right? But the one with the fly roof has got a more comfortable trajectory through the day, okay? So these are the sort of things that you can do by using that result viewer file. My suggestion is always try on a simple model, set up a simple one bedroom, one room, two room type of model, test your strategies on that, then apply it on the big model. If you make a mistake on the big model, it's very difficult to try and figure out what's going on. There's thousands of variables and things. So, you know, if something doesn't look right, you are struggling to find out what's going on. If you test it on a small model, you know, then you can put it on your other bigger model once you're sure it's doing exactly what you want it to do. So we're almost exactly at 6 o'clock. I think I'm going to leave it there and we'll take some questions.
Sure. Thank you, PC. So we have had a few questions coming in, and I'll just get to those. So one question we have is, can the software provide information for a new mixtured material, like if the assembly has cow dung, lime, gypsum, etc.? So is the software capable of providing U value for the entire assembly?
If they are, okay, let me go back there. And see the way in DesignBuilder and any other simulation model, really, it's not just Energy Plus or DesignBuilder, any simulation program that you pick. The way you calculate the combined U value, R value is always based on the properties of each layer, right?
Just
If you
sorry
have
sorry to interrupt. We're not able to see your screen if you are.
Oh, sorry. Hang on a minute. Hang on a minute. Hang on a minute. Sorry, I think I stopped sharing there. Yeah.
Yeah, no problem.
Let me know when you can see it. Can you see that now?
Yes, yes.
Okay. All right. Thank you. So I was saying, this is your external wall. It's made up of 3 layers, and each layer is a material. And that material has got physical properties of conductivity, specific heat, and density, okay? If you have defined layers made up of defined materials, which have got these values behind it, no problem, okay? But if you are making a concrete mix, which has got cow dung in it, and sand in it, and Busca in it, whatever, then you need to take it to CBRI. CBRI has got to do those measurements, give you the density, specific heat, and conductivity, put it into DesignBuilder and you can use that material. Call it whatever you like, right? But if they are distinct materials, no problem. And you'll find, I think there's even mud fusca in the materials.
Yes,
In
yes,
DesignBuilder.
it's there. Yeah. Okay, thank you. Moving on to the next question. So when simulating for ventilation, as you did a while back, it shows weather data file is not been installed. So what do the participants do in that case?
Are you trying to install a file that is like DesignBuilder comes with a series of weather files that are built in, right? Now, if
Right.
you want to use a file that is not one of those, then there's a process of manually installing that file. But I would say that for most locations in India, there are files attached to that. So any of the locations that are here, if there is an ISRI weather file that is for that location, it's already in there and it will download it automatically. If it hasn't done that, then there's something wrong with the installation. Now, the first time you run a new location, it will ask your permission to download that file from the UK website and install it on your local machine. You have to say okay to that and it should work. So suppose I pick up, let's say Trivandrum, okay, and I change the location, then it will pick that up. Okay, so it's still going round and round, but it will put the right file in there and then it will do the simulation based on that. So if there's a problem with that, then maybe try putting the location in one more time, do a simulation run and it should install it. It'll ask your permission to do that and install it. Yep.
Right. Okay. Thank you. Next question. Is there any provision to check the effect of breathable materials on the thermal and air envelope?
I'm not sure how that works. I mean, when you say breathable materials, are you suggesting that there is a airflow rate that comes with it, or are you talking moisture migration through vapor pressure? Can whoever asked give me a...
So this question was asked by Vanshaj Mehta, and if you could provide more details, I can take this question up once again in some time, and we can move ahead to the next question.
Sure.
By then. We have got a response. So it's like a porous material. If we're talking about a porous material as a breathable material in that scenario.
Yeah, so that's vapor pressure basically.
Yes.
Now within Energy Plus, there are some equations that talk about moisture migration through constructions. Okay, and I haven't personally tried them, but I've heard from people who've tried them that it is the fastest way to slow down your simulation by a factor of 10. Okay, so use with caution and please read the manual on that. If you look for moisture migration through materials, it's there. Okay.
Right. Okay. Next question. Is it possible to factor in the effects of context buildings on the wind flow, heat influx through the envelope, etc.?
Yes, certainly for heat. You remember I showed you the way that I drew that component block as a fly screen roof. In the same way, you can model blocks, surrounding buildings as component blocks, and they will provide all the sun shading, etc. Okay. Now the wind effects are a little bit more suspect. They're not that easy to model. If you have a series of default pressure coefficients for a location that, in fact, I think it's like a default set of pressure coefficients for most models. But if you have pressure coefficients for your location, you can certainly change those and then it will start to take those into account. But of course, that means you need to go and test, what's going on around the local climate there.
Right. Yeah. Okay. Next question. Can we make modulation and simulation of solar powered refrigeration system in DesignBuilder?
Ooh, um, tough question that. Um, I would say that you have a PV system which generates electricity. You also have a solar thermal system that generates hot water, right? So depending on what your refrigeration system is, if it's a refrigeration system that is powered by electricity, then you just model it as a normal electrical air conditioning system, and the PV system will offset the energy use against that. If it's a solar thermal refrigeration system, then things are a little bit more complicated. I'll try and find out about that. It may be possible, but the engineering behind that is pretty complex. Okay, there is a fairly good model for a solar thermal hot water system with heat exchangers and hot water vessels and flow controllers and pumps and all of that, which you can put together. But I'm not sure we have like an absorption cooling system which will work with that. Yeah, that's a bit complicated.
Right. Next question. So when I import a .dxf file from CAD to DesignBuilder, it shows an error. Is there any limitation to that?
When you import a DXF file, there's a few things to kind of think about. You must make sure that your units are correct. So when you import it, you must tell DesignBuilder what's the DXF file's units. Is it in millimeters, meters, feet? Sometimes that can give you errors. Sometimes, and I have to ask one of my colleagues, she's much better with importing CAD models than I am. Sometimes it'll give you an out of range error, and that's when you have, I think, too many models on the same drawing and you're trying to import everything. If there's a problem, we can probably help sort it out. But typically, if you've got your units correctly, it's not a bother. Yeah.
Okay. Thank you. Next question. Can we simulate comfort hours inside the building?
Oh, yes, of course. That's what it's all about.
Yeah.
So it depends on how you want to measure comfort. If you want to put it as PMV, you can certainly do PMV, right? I'll cancel that, sorry. So it will report hourly PMV. It'll report adaptive comfort as per ASHRAE 55. It'll tell you whether it's met it or not. And we're a few months away, but at this point we are just talking with Professor Rajan Royal at CEPT to develop a plugin for adaptive comfort according to what the NBC has just put out. So hopefully, well, I'm unfortunately not for this one, but hopefully the next solar decathlon, we might be able to have a plugin that we can provide, which will auto calculate that. That's a post-processing. So you can take the ESO file, take the values that you want, and post-process that in an Excel sheet. No problem.
Okay. Probably we'll have something by the next session we have with you, probably in January. That's
I may
okay.
not be.
All right.
Probably
okay.
March next year is what we're looking
Okay.
at. I think.
Yeah. So probably next solar decathlon. Yeah. All right.
Yeah. What I can say is that if you take this ESO file, right, what I was showing you, once you select a series of variables that you're interested in, what you can do is you can save only these variables onto a CSV file, which then you can open in Excel, and then you can do post-processing. So you can pick up all the variables that are used to generate that adaptive number that you're looking for, and then post-process that for each zone.
Okay, right. Next question. So if we are selecting a VRF system and for simulation, is any performance curve required additionally, or is it a default in DesignBuilder?
Very good. It's an Energy Plus model for the VRF. It's pretty good. It's based on a Daikin system, and it's the output of a PhD that was done, I think, in NREL or LBNL. So it's a pretty sophisticated model. I wouldn't suggest you change the curves. There are some 20 or 22 curves for just that one model, but it does allow you to set a design COP, which you can change. So the same curves will modulate the part load performance, but you can set the design COP so that the maximum will be limited to whatever you set.
Right. And I think we'll take a couple of more questions here, PC. One question again about getting a SketchUp model into DesignBuilder. So from SketchUp, I am not able to save it as a DXF file because there is no option in SketchUp.
Yeah.
So what do we do there?
Can you export as a GBXML?
Yes, I think DXF is from DWG when we do it via AutoCAD. But when we do through SketchUp, I think it has to be GBXML, but I'm not sure.
GBXML.
Yes.
Yeah, I believe that's probably the only way, yeah.
Yes. Yeah.
I will do one thing. I have a colleague, as I said, she's much better at CAD than I am. I'll ask that, but I think I'm fairly sure that with SketchUp, it's the only ways to be able to, from SketchUp, to export to GBXML and then import that into DesignBuilder. Try and keep the model as light as possible. Make sure that all spaces are enclosed spaces. So you have 6 surfaces, because otherwise you lose something in translation. It's always hard to do those sorts of translations.
Yeah.
Again, PC, jumping in here, especially in the early stages of design, when these students are and these teams are trying to understand the impact of certain energy conservation measures, it might be easier and more appropriate, do you think, to just use those simple models you construct in DesignBuilder and run them there to get an understanding, rather than trying to import complex models right now?
Yes, certainly. I mean, most places where we do work with DesignBuilder, you can do the massing in very simplistic ways in DesignBuilder directly, and that'll give you very good ideas of where your model is traveling. The detail can be done later on. You can do things like you just work your blocks up, give it percentage ratios for windows, which are the main thing. Then you can do your shading devices can be done very easily. So those are easy to do. And I think what you just said, Prasad, that's a really good way of starting.
Right. And another question, how do we introduce our innovative HVAC system in DesignBuilder?
I think you will have to define innovative. You have all the building blocks of typical air conditioning systems. So you've got, chillers and boilers and pumps and fans and, all those different components are there. And control strategies for each of those are there, and connections for each of those are there. So unless you come up with innovative compressor technology, which is not a component in in design, well, Energy Plus, and then reflected through DesignBuilder, you can do many things. You can't do all things because air conditioning systems are just too darn complex, but you should be able to do most things. If there is like I said, your definition of innovative is probably the key in there.
Right. And with that, I think we are towards the end of our session today. Thank you, PC. I think the Q&A was very helpful, and I hope our participants can make the best use of DesignBuilder in their net zero energy design development. Thank you everyone for participating today, and we intend to have another session with PC in January, where he will talk about a more detailed use of DesignBuilder for optimization and for modeling of HVAC systems. And we will see you next week at 4 p.m. for the webinar on water sufficiency. Thank you, everyone.